All right, in this video, I'm working on some application problems from 7.1. So they're probably going to require the law of sines for the most part. All right, in this particular problem I'm doing, they're wanting us to find the length of the side CD that they've labeled with an H, okay? So they want us to find the length of that side. All right, now you got to be careful about what you see. Okay, so the 388 is the distance from A to B. Okay, if it had been the distance from A to D, I would have approached the problem a whole lot differently than I'm going to approach it. So I like to kind of think through what I'm going to be able to do. I'm thinking if I can get either little BD, the length from B to D, or get the length of the side from like B to C, then I'll be able to work on this right triangle over here and use what I know about right triangles to find H. So that's going to be my plan, I think, is to go ahead and get what this side is. I'm going to label it with a little a since it's opposite angle A. And I know I can find that because I have a length of the side in that triangle, and I have this angle that's 23 degrees right there. So I think I'll be able to do what I need to do. Now I will need the little angle there at the top. I would need the angle that's opposite this 388. So that would be this little angle C right in here. But I'll be able to find that because you see the 59 that we have down at the bottom? That angle together with this guy right here has to add up to be 180. So I'm going to do the 180 and take away the 59. And that's going to give me 121 degrees. Okay, so that represents the angle within that triangle. All right, and then I have two of the three angles in that triangle ABC. So to find C, I can take the 180 minus the 23 and the 121, and that will give me the measure of angle C. Okay, so let me find out what that turns out to be. 180 minus 121, and then minus the 23. And that means that this angle right here is 36 degrees, this one. That's really the one I wanted because I was trying to get the ability to set up a law of sines proportion that would involve angle A and the side opposite, and then angle C and the side opposite. Okay, and what I'm looking for is little a, so I like to have that on top left. It's easier that way, easier algebraically. So little a over the sine of 23 should equal little c, which I know is 388, over the sine of angle C, which we just worked out to be 36. Okay, so I'm going to multiply by the sine of 23 degrees on both sides, and I'll get that A is about, I'm typing this in right now, you should do the same, and double check yourself because I typed 38 instead of 388. My calculator is always kind of sticky, like it doesn't, the buttons don't always work correctly. Okay, so I always have to double check. Divide by the sine of 36. All right, and I get A to be about, it seems big, A to be about 257.9. I might keep to the hundredths until the very end. So if I keep to the nearest hundredth at that point till I get to the very end, and then they want me to round to the nearest tenth, but so I'm to here. All right, now look at where A is in that triangle. I'm going to redraw that triangle kind of separately. So now I'm just going to be focusing on that triangle. Didn't get the angle quite right. Okay, so I'm going to just extract that triangle out. Okay, still did a bad job, but oh well. One more try. Okay. All right. So I'm trying to find this. And so let's get rid of all that stuff I don't need anymore. And this side over here, I know is 257.92 about, okay? And I know this is 59. All right, so what I'm gonna do is I'm gonna notice, hey, this does have a right triangle. So I can use SOHCAHTOA since it is a right triangle. Okay, couldn't do it on the earlier one. So I'm just going to set up the ratio. So I'm looking at that and I'm thinking, okay, if I did the sine of 59 degrees, it would have to equal h over 257.92. So if I multiply by the 257.92 on both sides, make sure you're multiplying, that should give me my h. And when I do this, I'm going to go ahead and round this one to the nearest 10. So I'm going to take that 257 thing times the sine of the 59. And when I do that, I get 221.1 when I round to the nearest 10th. And that problem didn't have any units on it anywhere, so I don't have to worry about that. But I get 221.1. And that's what they wanted. That's what would go in the box. Well, so I thought we'd look at that one because they really didn't give you a hint on that preliminary step. And also I'll let you know, there's multiple ways you can approach the problem. So you may do it differently than I do, and that would still be okay. So like, you could have found this angle and then used the big angle and found the whole side AD. There's a lot of variations that could have happened on this problem and would get us all to the same point ultimately, okay? All right, so let's look at another one. All right, so here, I just drew the picture, but what was going on is we had a beach. This is a beach right here. And the beach is 1,300 yards long. And then there's an oil platform off the beach. And when you're on one end of the beach and you're sighting to the platform, the angle there is 75 degrees. From the other end of the beach, when you sight the platform, it's 85 degrees. And what we want to know is how far is it to the oil platform from each end of the beach? Just how far, not the bearings or anything like that. Okay. All right. So we want to find the X and Y. How far to the platform from either end. Okay. So when you're looking at that, we know this angle, but we don't know what's opposite it. We know this angle, but we don't know the length of the side opposite it. Okay. And then they didn't give us the angle there at the top, but we do know the side opposite that one. So we really do need this angle right here. And if you have two angles in a triangle, you're going to be able to find the third one. So 85 plus 75, that would be 150, 160. So that means you'd have 20 degrees left up here at the top. And so that angle has to be a 20. So now that we know that, we can set up two proportions that are going to help us find each of these. We know X over the sine of 75. So X over the sine of the angle opposite that would have to equal 1,300 over the sine of 20. And then we know Y over the sine of 85 degrees would have to equal 1,300 over the sine of 20. Okay, so I'm going to multiply by the sine of 75 degrees on this one. Let me go ahead and do that step over here. I'd multiply by the sine of 85 degrees there. And actually, I'll just find X. I don't think you'd have a problem finding the other ones. So I'll just find X. All right, so we wind up with X equaling, and we'll do the 1,300 times the sine of 75 divide that by the sine, don't forget to hit the sign again, of 20. Okay. And that gives us about 3,671. Let me see what they wanted us to round to on that one. On that problem, they said round to the nearest tenth. So that would be 0.4 yards. Okay, so that would be X. And you would do a similar thing to find the Y. Okay. Do the same here. Do the same thing here. Okay, but I'll let you do that one. All right, now I just want to do a follow-up question. What if they had asked us, what is the bearing to the oil platform from maybe this side, from where the 85-degree angle is? So what is the bearing? So what if they asked us, what is the bearing to the platform from the left side of the beach? Okay. All right, so then you would need to determine, because you're going to be leaving from the beach. So it's starting at the beach, heading to the platform. So you would need to get your coordinate plane set up there. You'd need to think about how you don't need the 85-degree angle. You need that little angle right there, okay? And that little angle would be, wow, just 5 degrees, right? Just 5 degrees. Okay, so now you got to think about, if this is how you're going to be traveling, how to report that. So do you see how it's north, and then you're going to veer just a little bit, 5 degrees, and that's making the assumption. That's assuming that this is east, that the picture is drawn in the right thing. So let me add that assumption to my what if. Okay, so let's assume that the beach is oriented east-west like this. All right, then it would be north 5 degrees east. Okay, I just thought I'd throw in a bearing one. Okay, now let's see if we can get this one. Here's a bearing problem. All right, so here it says we have 2 fire lookout stations that are 19 miles apart. Station B is directly east of A, so it's got to be to the right of A. So let me get that drawn. So here's A, here's B. Okay, I better move it down a little bit because we might have to go north from these. So I'm not sure which direction we're going. So let me just move it more in the middle here. So here's A and here's B. Okay. And B was directly east of A, so that's why I drew it on the horizontal to the right of A. All right, and I know they're 19 miles apart, so I know this right here is 19 miles. And then it says both of them spot a fire. The bearing of the fire from A is north 35 degrees east. Okay, so when I think about that, that means I have to put my coordinate plane at A. I have to imagine going north, veering towards the east, 35 degrees. So something like that, with this angle being 35 degrees. Okay. So I don't know how long to draw that, but that's the bearing upon which I would go. Okay. All right. Now it says the bearing of the fire from B is north. So let me get my coordinate plane on there. Let's try that again. Okay. All right, so it'd be north and then 30 degrees west, towards the west. So north, and then it's going to veer this way a little. And that's 30 degrees right there. Okay. All right, so that means, let me go ahead and make this red so we can see where it is, because it's going to go up into the words. So this would continue, and that would continue nice and straight, not all squiggly like that. And right there is the fire. Okay. So we're going to figure out how far the fire is from each station. Okay. So I'm going to find out this, I'll call it X, and this, I'm going to call it Y. Okay. All right. Now remember, even though they don't quite look like it, I'm not even going to try to redraw it. Remember that these are going to be 90-degree angles right here. So I can find the remaining angle by just subtracting from 90. So 90 minus 30 would mean this is 60 right here. And 90 minus 35 would be right here, 55 degrees. Okay. All right, so now I have some angles in the triangle. I've got that side right there being 19. And I want to use the law of sines, but to use the law of sines, I would have to know this angle. Well, we can find that angle now, can't we? Because we have the 55 and the 60. So the 60 and the 55, they're inside the triangle. And so we can take the 55 and the 60, add those up, and take it away from 180. That means we'd have to have this angle being 65 degrees right here. All right, so now we're going to be all set. We can set up two different ratios. It's very much like, now that I've drawn it, it's very much like the oil platform problem, okay? So now I'm going to say I'm going to try to find X. I'd like the X on top left. So it would be over the sine of 60, and it would equal the 19 over the sine of 65. And then we could do a similar thing to find Y. We could take Y over the sine of 55, and it would equal 19 again over the sine of 65. All right, so I'll just do one piece of the solution of that. Okay. Sorry. All right, I think I can get it in here. So if I wind up multiplying by the sine of 60 degrees, okay, then I'll get what X is. So X should turn out to be about 19 times the sine of 60, okay, which would equal that. Divide by the sine of 65, and I'd get about 18.2, and the units would be miles. So this would be 18.2 miles, and that would be from Lookout Station A, okay? All right, so when you're doing these problems and you go to enter it back into MyMathLab, pay attention to which spot. I thought it was kind of weird because they wanted station B first, and then they wanted station A, and I almost wrote it in the wrong spot when I did it. Okay. All right. So those are just a few of the application problems that you see on the 7-1 Law of Sines homework. Okay. All right. So I'm going to stop.